What do we mean by speed in physics? The speed tells us how fast an object is traveling. You understand? The speed tells us how fast an object is traveling, and it is expressed mathematically as speed. Speed is equals to distance all over time. That is the mathematical expression of speed. So the speed tells us how far the distance of an object is changing with respect to time. You understand? The speed tells us how fast the distance of an object is changing with respect to time. Let's say we have a speed of 40 meters per second. Distance is measured in meter. Let's say we have this speed 40 meters per second. Distance is measured in meter. It's very, very important that you note that distance is in meter, okay, and time is in seconds. Do you understand? So that means that we have this distance, we have this speed 40 meters per second. That means that every 1 seconds, the distance of this object traveling at this speed is changing by 40 meters. Are you getting it? So for the first 4 seconds, the distance is what? 40 meters. The next 1 second, that is the second one, the distance is what? 80 meters. For the third, the distance is what? That is 80 plus 40, that is 120 meters. You understand? So the distance tells us how fast the distance of an object is changing with respect to time. No, I mean the speed. Please, I want to take notes. I made a mistake. The speed tells us how the distance of an object is changing with respect to time. Are you getting it? So now look at this. The first seconds, when the speed is 1 second, the distance is what? 40 meters. When it changes to 2 seconds, the distance is what? 80 meters. When it changes to the 3 seconds, the distance of the object is what? 120 meters. So therefore, the speed tells us how fast the distance of an object is changing with respect to time. So when you are told to define speed in physics, speed refers to how fast an object is traveling. Are you getting it? Now, it is important to note that peradventure, if you are given a question and the distance is in kilometer, you first have to convert to meter before you can proceed to calculate your speed. Do you understand? So, and if your time is also not in seconds, peradventure, if you are given a minute, the time is a minute, you have to convert to seconds before you can calculate your time, before you can calculate your speed. Do you understand? And also, I want you to note that since speed is distance over time, that means that speed is represented as v. V is equals to d, which is distance, all over t. Do you understand? This is the equation connecting speed, distance, and time. This is the equation. The equation connecting speed, distance, and time is what? Speed is equals to distance over time. And since speed is distance over time, this means that speed is a scalar quantity. Do you understand? Speed is a scalar quantity because it involves distance, and distance only has magnitude but no direction. So speed is also a scalar quantity. Now we have two scalar quantities. The first scalar quantity is what? Distance, and the second is what? Speed. Please, I want you to note that. It's very, very important. So now let us proceed. Let us have some work example on speed. Question 1. Given that the speed of an object is 50 meters per second, how long will it take to travel a distance of 100 meters? Now, let's first write out the parameters that we are given in the question. We are given that the speed of the object is 50 meters per second. So, v is equals to 50 meters per second. Do you understand? And we are now given that how long will it take to travel a distance of 100 meters? So we are given that distance is equals to what? 100 meters. Do you understand? Now, let me tell you. In order to determine the parameters that you are calculating, you first have to write out the parameters that was given. We already know the equation that is connecting speed, distance, and time. Now, from this, we are given the speed and the distance. That means that we are told to calculate the time. Are you getting it? So in order to calculate the time, we are going to use this formula. V is equals to what? Distance over time. So the speed has been given as what? 50 meters. So this will be what? 50 meters per second is equals to the distance. The distance has been given as 100 meters. So equals to 100 meters all over time. Do you understand? Because the question says how long. That is talking about time. Are you getting it? How long will it take to cover a distance of so? How long will it take to cover a distance of 100 meters? Therefore, we are looking for time. So now, in order to calculate the time, we have to just multiply both sides, cross multiply. We are going to have t multiplied by 50 meters per second is equals to 100 meters. Divide both sides by 50 meters per second. T is equals to 100 meters all over 50 meters per second. So the time is equals to, this will cancel this, and meter will cancel meter. So I'm left with what? Seconds. So T is equals to 100 divided by 50. That is what? 2. So the time is equals to what? 2 seconds. Or you can leave it like this, 2s. You understand? So the time is 2 seconds. So for the object will cover a distance of 100 meters in 2 seconds. Do you understand? The object will cover a distance of 100 meters in 2 seconds. Now, another concept of speed that I want us to talk about is the uniform speed. An object is said to undergo uniform speed when the object travels equal distance at equal time interval. For example, let's say a motor is traveling. Let me just represent this shape as the motor. Let's say the distance between this distance is 10 meters, and the seconds here is 2 seconds. Then it covers another distance, 10 meters, another 2 seconds. It covers another distance, 10 meters, in another 2 seconds. This motor is said to undergo uniform speed because the motor covers an equal distance as equal time interval. Do you understand? No matter how small the time, the distance may be. Let us proceed to velocity. Now, in physics, what do we mean by velocity? Velocity is related to speed. The only difference between velocity and speed is that velocity is a vector quantity and it is expressed mathematically as v is equals to displacement all over time. The only difference between velocity and speed is that velocity is a vector quantity while speed is a scalar quantity. And don't forget that I told you scalar quantity has magnitude and what? Scalar quantity has only magnitude while vector quantity has magnitude and direction. So therefore displacement has magnitude and direction, and velocity is related to what? Displacement. Velocity is directly proportional to the displacement. So therefore velocity is a vector quantity. Now, when you are given a question and the magnitude of the distance is given and the direction was given as well, that means that we are talking about velocity. Are you getting what I'm saying? So velocity is expressed mathematically as displacement all over time. Now let us have some work example on velocity. A motorist travels 40 meters east in 5 seconds. Find its velocity. Okay, let's start by stating all the parameters that was given in the question. The motorist traveled 40 meters east. You can see that means that 40 meters east. So we have the distance, which is the magnitude, and the direction, which is eastward. So therefore, this is what? Displacement. You understand? So the displacement is what? 40 meter. You understand? So in 5 seconds, the time given in that question is 5. Do you understand? 5 seconds. So we are told to calculate the velocity, and the velocity is given by this formula. V is equals to displacement all over time. You understand? You can see that this formula is also related to the speed formula that I gave you the other time. So, but the only difference is that when we are dealing with velocity, the d here is not distance, it is what? Displacement. You understand? So, and the v here is not speed, the v is what? Velocity. Do you understand? So that is it's very, very important that you note that. Okay, let's proceed to calculate this question. The velocity now becomes, displacement is 40, so displacement is 40 all over the time taken is 5 seconds, so displacement over time, that is v. V is equals to 8 meter per second, because displacement is in meter. It is very, very important that you note that displacement is in meter and time is in seconds. You understand? So now let us proceed. Let us summarize what we have learned so far. There are 4 key points that I want you to note. Number 1, speed tells us how fast an object is traveling. Okay, the speed of an object tells us how fast the object is traveling, and speed is a scalar quantity. Are you getting it? Speed is a scalar quantity. That is point 2. Are you getting it? So speed can only be positive, while velocity can be negative or positive. This implies that when speed has direction, it becomes velocity. When direction is removed from velocity, it becomes what? Speed. You understand? For example, please, I want you to pay attention. For example, speed is what? Distance over time. And distance does not have what? Direction. Are you getting it? So 40 meter is what? Distance. But immediately they say that 40 meter east. That means that we have already had direction. So this becomes what? Displacement. And okay, now let us have another work example on speed and velocity. An object traveled 10 meter east and then traveled 20 meter west. If the total time taken is 5 seconds, calculate the average speed and the average velocity of the object. Okay, let's start by listing the parameters that we are given in the question. The first part of the trip of the object was that the object traveled 10 meter east. So we have the first distance, first displacement, F-I-R-S-T, first displacement. The first displacement is that is 10 meter east. 10 meter east. Okay. Then the second displacement, that is 20 meter west. Okay. 20 meter west. The total time taken is 5 seconds. Time is what? 5 seconds. Okay, now we are told to calculate the average speed and the average velocity. Now, I want you to take notes. The average velocity of the object is what? The total displacement all over the total time taken. Are you getting what I'm saying? The total displacement all over the total time taken. Let's start with the velocity. Average velocity. Velocity. Oh, let me get another. Okay, average velocity. Average velocity. Okay, is equals to total displacement. Total displacement all over the total time taken. Okay, total time taken. Okay, now please, I want you to pay attention here. Let us represent this on the number line. Okay, let us represent this. The displacement on the number line. Now, the first part of the trip was that the object traveled 20 meters to the east. From our 4 cardinal points, we know that this is north, this is south, this is west, and this is what? East. Are you getting it? So the object traveled 10 meters east. So it traveled along this side. That is 10 meters. Okay. Now, The second part of the trip was that the object traveled 20 meters west. Are you getting it? Therefore, after reaching this point, the object traveled back 20 meters west. Okay, this is 20 meters. Are you getting it? Please, I don't want to get confused. Okay, now for in our number line, don't forget that there is a point known as point 0. Abi, every other part of this place will be positive. Is that not it? This is what? Negative x. But along this side will be what? Negative. Are you getting it? This is positive x and this is negative x. Even just take note of the graph. When you have a graph like this, when you have a typical graph, this is positive y, this is what? Negative y. This is positive x and this is what? Negative x. Do you understand? So now, the first part of the trip was that the object traveled 10 meters towards the west, which is along the positive x-axis. Are you getting it? So this is positive. Then after that, it now take another trip towards the negative x-axis. That is 20 meters to the west. Are you getting it? So now, we want to find the displacement of this object. The displacement is simply minus 10. How do I get that? From this point, the total distance from this point to this point is what? 20. Hey, let me get another marker, please. The total distance from this point to this point is what? 20 meters. Okay? So now, if the total distance from this point to this point is 20 meters, but it traveled from this point 10 meters. So 10 meters minus 20 meters, that is what? Minus 10 meters. Do you understand? So the total displacement is what? Minus 10 meters. Because if I want to measure the displacement from this point to this point, that is what? Minus 10 meters. As it falls along the negative x-axis. Do you understand? Please, I want you to understand, okay? This falls along the negative x-axis. This is the point 0. This point is point 0. The first part of the trip is that it travels 10 meters. That is positive. But after that, it travels another 20 meters towards the west. That is, after getting to this point, every of this displacement becomes negative. Are you getting what I'm saying? That is, from this point to this point is 10. After that, after covering the distance that it travels towards the east, then it proceeds, the displacement becomes negative. That is why I have minus 10 meters here along the negative x-axis. Are you getting it? So when an object travels along the negative x-axis, that means the displacement will be what? Negative. So the total displacement D is equals to 10 meter minus 20 meter. This is equals to minus 10 meter. So the average velocity is equals to the total displacement, which is minus 10 meter all over the total time taken. The time taken is what? 5 seconds. So I'm going to have 5s. So the average velocity is minus 2 meter per second. Do you understand? So now let us proceed to calculate the average speed. Don't forget that the formula for average speed is equals to the total distance all over the total time taken. Okay, the total distance all over the total time taken. So now the average speed is total distance. The total distance is the distance that the object used to travel to and fro. You understand? That is the first trip that is covered by the object, which is 10 meters. The total distance is 10 meters plus 20 meters. Do you understand? 10 meters plus 20 meters all over the total time taken, which is what? 5 seconds. So that will be what? 30 meters all over 5 seconds. So the average speed is equals to 30 divided by 5, that is 6 meters per second. Do you understand? So because the total distance is the total length traveled by the object. Are you getting it? Now I want you to take notes. Speed can only be positive. Speed cannot be negative, okay? But velocity can be negative. because speed refers to the distance traveled by the object all over time taken, and the distance is the total length traveled by the object. We are not taking into consideration either positive or negative sign. Are you getting it? But in displacement, in displacement we are talking about the shortest distance traveled by the object. Are you getting it? So the shortest distance traveled by this object is what? The distance from this place to this place. Are you getting what I'm saying? So that is why we have negative minus 10 here. Please, I want you to take note. Velocity can be positive or negative, but speed cannot be negative. Speed can only be positive. That is another thing I want you to note. Okay, so now from what we have learned so far, we knew that speed is a scalar quantity while velocity is a vector quantity, and speed can be only positive. That is, we can only have positive value for speed, we cannot have negative value, but velocity can be either positive or negative. For example, in this case, we have the velocity here is what? Negative 2 meter per second. Do you understand?